So we move on now to the second part of this video sequence, where previously we talked about sort of changing one expression into a trig expression. This next part is now about how do we rewrite abstract trig expressions. I know that doesn't mean very much, but I'll try and clarify that with a goal, and then we'll definitely get into some examples that will show it. Our goal is, if I give you one trig ratio for an angle, so like if I tell you that the sine of an angle is 1/5, can you tell me what the trig ratio, what any other trig ratio of that same angle is, right? So our strategy for this, and this is something we've done before, we would have done it in math analysis and a little bit last year in calculus. The strategy is first draw a right triangle. We're effectively going to draw the unknown angle we're working with. 2, you'll label the two sides that you're given and the angle from that one trig ratio. 3rd, you'll use the Pythagorean theorem to find the third side, and 4th, you'll find, whatever ratio you need to find. So let's get into one simple review example of that, and then into 2 more examples that have a little bit more substance to them. So here's my first review example, right? Given that the sine of some angle is 2/3, find the tangent of that angle. Well, I copied back in our strategy from the last page so you could sort of see step by step how we do it. Right? So the first step is to draw a right triangle. You may remember from math analysis or from calculus that it depends on what quadrant we're in. It sort of matters for this one because we're actually working with a number. In the later problems, it really doesn't matter. I'm always going to draw it like this. So I drew my right triangle. Next up, we label the two sides and the angle. And really, I should have said label the angle first and then the two sides, because it's really important to set your angle first. So my angle in this problem is x. I'm going to put the x right here. And then, because it's sine x is 2/3, this means that the opposite over the hypotenuse from angle x is 2/3. So 2 is this, 3 is this. Right? 3rd, we're supposed to use the Pythagorean theorem to find the third side. So this side down here would be the square root of 5. I get that by doing 9 minus 4 and then square rooting. And then the 4th part is now finally solve the problem. Like really this entire thing is about set up this triangle and find out the other side. Then it doesn't even matter what they asked for. Right? Now I can answer any of them. Because they asked for tangent x will be the opposite side over the adjacent side, which means it will be 2 over root 5. If instead they had asked for the cosine of x, it's not like there's any different work. You would do all of the 1, 2, 3 steps, and then in step 4, that ratio would be adjacent over hypotenuse. So it would be the square root of 5 over 3. Okay, so that's sort of our setup. That's how we work through these types of things. So now, I want us to rewrite sine u cosine u in terms of x, given that 5 tangent u equals x. This may seem crazy, but the idea is, okay, they want us to rewrite this in terms of x. So I basically need to figure out what sine u is, and I need to figure out what cosine u is. And the one given piece of information is this, that x is equal to 5 tangent u. So when I see x equals 5 tangent u, I see that as, oh, that means that tangent u is x over 5. I just sort of gave the information in a slightly different way. So now, I need to figure out what sine u and cosine u are. Okay? At this point, I hope that the problem is doable and very accessible. So, pause the video here, sort of try and work out what this thing would be. If you're scared about it, maybe start the triangle, fill in the sides, and then sort of watch what I'm going to do and make sure you're on the right track. So, I set up my triangle. I label my angle as u. Now note, this time I made the angle u because the problem was set up as the tangent of u. Okay? Then my opposite over adjacent are x and 5. And then the Pythagorean theorem, and if you don't know how to do this clearly, you're sort of going like, well, this is question mark. Okay, so question mark squared is equal to x squared plus 5 squared, or 25. So that means that hypotenuse is this thing that I just found, the square root of x squared plus 25. Okay, so now they're asking us to rewrite sine u cosine u. So let's work that out. Sine u, cosine u. So what's sine u? Sine u would be the opposite over the hypotenuse. So it'll be x over the square root of x squared plus 25. Cosine u, on the other hand, is adjacent over hypotenuse, so it'll be 5 over the square root of x squared plus 25. And so finally, we can sort of put these things together and get 5x over x squared plus 25. And this thing is our answer. This thing is what is equivalent to, sine u, cosine u. I'm just writing it in terms of x given the substitution. Okay? At the moment, I'm sure this feels really strange. You're like, why are we doing this? In the third video, that will all become clear. We just need to work out this basic skill and make sure we can really do these things before we get into those problems. So now here's my third example, right? I want us to rewrite the sine of 2u in terms of x if the sine of u equals 3x. The one hint that I'll give you on this before I let you try and figure this out on your own is that there is a trig identity for sine 2x or for sine 2u. So you might want to sort of pause and think about what that is. If you don't remember, it's the first hint that I'm going to give, in about 3 seconds, so pause the video. So the hint that we're going to use here is that the sine of 2x is equal to 2 sine x cosine x. So when they ask us to find the sine of 2u, they might as well be asking you to find 2 sine u cosine u. And at this point, this problem should be very similar to the others. So pause the video, set up your triangle, work through this, see if you can get this rewriting done. So because the sine of u is 3x, I'm going to draw my triangle, make my angle u, and my opposite over hypotenuse has to be 3x. So this is 3x and this is 1. The third side of this thing will be the square root of the hypotenuse squared, 1, minus the other side, 3x squared, so 9x squared. Now that I have my triangle set up, I can sort of plug things in over here. Right? I have 2, then I have sine u. Well, it's interesting, sine u, we already know that's 3x, so I can just put in 3x. Cosine u is the one that's going to take slightly more effort. For cosine u, I'm supposed to do the adjacent side over the hypotenuse. So it turns out that it's the square root of 1 minus 9x squared. And that's basically it. I should just rewrite this, I suppose. This will be 6x times the square root of 1 minus 9x squared. So this thing is the rewriting of 2 sine u in terms of x. Now again, I'm sure this feels sort of like, why are we doing this? The thing that's important to me is if you understand how to do this, I hope that the next video will make sense of why we're going to use this and how it's helpful for us in calculus. I'll see you there. This is good stuff.